Okay, friends. Here, today's theory of failure is maximum principal strain theory. Till now, we have read two theories of failures. Now, this is another one, that is maximum principal strain theory. This works on the strain. Let's see that. First, I will now just see here. This is an specimen having a length L. Now, this is a change in length. That means due to the force, what happens? An elongation is being generated. This force and this force. Due to this tensile force, elongation is generated, and that makes a change in length, and that is was delta L. If the force is continue, the necking can be occur at this point, and after that, a failure will be there when the neck reduces in diameter. So this we know that this is a stress strain diagram and how it works. So failure theories is works on this theory only. Now this much is what our strain hardening part. This is the necking part where the necking occurs and here the fracture takes place. So these are the strain and these are the stress. Now this theory works on the strain. Okay, what amount of energy is stored in the material. So maximum principal strain theory, it is also known as the Saint Venant's theory. So this theory's definition is just similar to the other theories, that in a biaxial stress system, when the maximum principal strain in a biaxial stress system reaches the limiting value of a strain as determined from a simple tensile test. As I have already shown you the simple tensile stress, whatever the limiting value we get in that tensile test, if the component reaches to that point, definitely the failure will occur. So that's why we have to take a value under the limiting value of strain as determined from the simple tensile test. So mathematically we can show this thing in this way. This is the formula for it. Okay, by using this formula we can calculate it. So sigma t1 and sigma 2 are the maximum and minimum principal stress in a biaxial stress system. Epsilon, it is the strain at yield point. We denote strain with this letter, it is epsilon. 1 upon m, that is the Poisson's ratio. E is your Young's modulus, and Fs is nothing but your factor of safety. I have already explained the factor of safety to you. So the final equation which we get here is this thing. Here E will get cancelled. That's why it is given as sigma T1 minus sigma T2 by m. This is by m means what? 1 upon m, that is the Poisson's ratio. Sigma Yt upon factor of safety. So this is how we can get the, or you can design a component with the help of this theory. Now just see something about this theory, that is maximally it is not used properly because it has some limitation. This theory is totally based on assumption that inelastic behavior or failure governed by a specific normal strain, that time failure will occur at a particular part in a body only. Okay, so only straining is considering here, not anything else. That's why failure is predicted either on the principal strain, that is from principal stresses sigma 1 or sigma 2, or with the yield strength. Only these two things are there, that is tension and compression, which is not a limited, which is limited part. So in designing, we consider so many stresses which these theories are not considering.